Alright. Good afternoon, my name is Michael, and I will be giving you a simple problem of polar coordinates. This is the equation we're going to use, r equals 7 cosine 4 theta, and we are going to find one loop of this graph, and this is what the graph looks like. You can see you have 8 loops, and we're just going to look for one of these loops. Right? I'm going to use the equation area is equal to integral a to b 1/2 r squared d theta in order to figure that out. So we're going to start off with a equals, we're going to do 1/8 of this whole area from 0 to 2 pi of 1/2 7 cosine theta 4 theta d theta. All right, and that's basically plugging that into this equation. So is a is equal to 1/8. We're going to pull out this 1/2. 1/2. 0, 2, 5. And we're going to square this. So it's going to be 49 cosine squared 4 theta d theta. Okay. So the next step, we're going to pull out this 49. Is equal to, this is going to be 1/16. Oh, sorry. So this 49 is going to come out. So we're going to have 49. We're left with cosine squared 4 theta d theta. Okay. So we're going to use a half angle formula on this cosine squared 4 theta. So this will be 1 plus cosine 4. Oh, sorry. 8 theta over 2. This is what we were left with last time. Okay. So this is going to simplify to area is equal to 49 over 16 integral 0 to 2 pi. 1/2 plus cosine 8 theta over 2 d theta. Okay, now pause the video and copy down what you see, and I'm going to erase this. Okay, so we're going to integrate to area is equal to 49 over 16 integral 0 to 2 pi of theta over 2 plus sine 8 theta over 16. Alright, so this is going to be, this is going to be from 0 to 2 pi. I erased that because we already integrated, as you can see. Okay, so the next part is going to be plugging in 2 pi and 0 into this equation. So we have a is equal to 49 over 16 of 2 pi over 2 plus sine of 16 pi over 16. All that minus I'm going to erase this graph. I know you guys got it, so no worries. Alright, so 0 over 2 plus sine 8 times 0 over 16. Alright, so after integrating, we're going to have 49 over 16 times theta over 2 plus sine 8 theta over 16. Alright, so now we're going to substitute the 2 pi into theta. So we're going to have area is equal to 49 over 16 times 2 pi into theta, so sine be minus 0 over 2 plus sine 8 of 0 over 16. Okay, so now we are going to, you can see, yeah, the 2's here cancel out, and sine of 2 theta, or sorry, 2 pi, or sine of 16 pi, they're both going to be 0. So that doesn't matter what it's over, because if you have 0 over 16, it's going to be 0. So this is going to end up being 0, and 0 over 2, that's 0. And same thing here, sine of 0 is 0, so this just goes to 0. All right, so we're left with just pi. So the area is equal to 49 over 16 pi. All right, that is it. Thank you very much. Good afternoon. This is the second problem we're going to do. We have the equations r equals 3 cosine theta, which you can see here is graphed out as just a circle. And we have r is equal to 1 plus cosine theta. And you can see it here as a heart in black. All right. And what we want to look for is the area inside this equation, but not inside this equation. So it's this area minus the overlapping area of this equation. Okay, and we're going to use the area equation for polar coordinates. And since we're subtracting areas, we need to subtract the equation of the outside minus the equation of the inside, both squared. So we're going to start off plugging them in, or excuse me, I'll edit that. First we need to find out where the points of intersection are for these graphs. So we'll start off setting them equal to each other. So we have 3 cosine theta is equal to 1 plus cosine theta. So we're going to subtract cosine from both sides. So we're going to have 2 cosine theta is equal to 1, dividing by 2. Cosine theta is equal to 1/2. So theta is equal to pi over 3, or negative pi